Hey guys and girls, welcome back to another beautiful video on this beautiful channel on this beautiful day. How are you guys and girls doing? I hope you're doing great as always. Please drop a like, subscribe if you like the content, if you're liking these Unity tutorials. Today's going to be about fixing some issues in the code. We're going to add a camera controller, and we're also going to add a background and a parallax effect to give you that cool 3D depth effect. So to get started, the only thing I'm going to do in my movement script right now is I'm going to fix a few things. Now, as you can see, is a few indiscrepancies. So we have a null set here. We don't have it set here. We have all this happening where it's getting the default rigid body, sprite renderer, and animator. Now, what can happen is when these don't exist, you're going to get an error message, but it might be hard to read out. It might be something that you don't know what you're looking for, basically. So what we're going to do is we're going to set all these to null and just look through here so everything is null. And once we've done that, we're going to create an if statement here. So if player rigid body 2D is still null when we're at the awake state, we're going to say debug.log exception and new null system.null reference exception. And then we're going to type a little message here. I'm going to tell ourselves basically what happened. So the player rigid body 2D not assigned. I think that's simple enough. So once we have that, we'll know what's going on. Now it won't do it by default. It won't get this by default. And I'm not going to do that either because I really want to force the user to place all of these in so they know what's going on. Sometimes if you don't assign things properly, you won't know what's going on. Maybe you've assigned something that's wrong there or something like that. So it's always good to make sure that you get an error when stuff isn't the way you want it to be so you can fix it later. Now we're just going to go through and add all of these that are null for the bottom collision point as well. I'm just going to copy the player sprite renderer as well. And the animator, of course. Player animator. Oh, what the hell just happened? Animator. And then I'm going to hit up the final one. Camera transform. There you go. Camera transform not assigned. So now we have all of these set to a state where it will log an exception once any one of these are at null. That's good. And what that allows us to do is it allows us to remove the if statements here. So we don't have to deal with that. So we're forcing it basically. We're forcing that we have an animator, we have the camera transform, all of that stuff is kind of forced. So we don't need these if statements. There you go. I'm just going to go ahead and test this and see it works. All right. So everything works. The camera is following, everything's animating, everything's cool. You might go in and check your actual references as well. So everything looks good. Cool. So that was the code fixed for now. Now we're going to make a little more complicated camera controller. Now, if we look at our movement script, we have a really basic camera transform, which we're following around. So it's a very, very set. We can't really customize this a lot, or we can, but it's not going to be pretty if we do that in the movement controller because it doesn't really have to do with movement directly. It's just supposed to be dependent on the movement. So I'm going to remove this code right here. I'm going to Control X that, and I'm going to save. And I'm also going to remove my camera controller or camera transform code from awake and from this camera section. And then you have to remove the final space here as well. Or what I usually do is I just comment it out in case I add another section. Cool. I will head back into Unity, make sure everything works, run it once, jump around, and the camera should be fixed in place. Yep, no errors. Now I'm going to add a new folder here. I'm going to call it camera. Inside, I'm going to add the new C# script and call it camera controller. Cool. And I'm going to select my player and I'm just going to drag it in just so I have it down here. Let's go ahead and open the script. And first things I'm going to do is I'm going to add a awake function like that. Now we got to do all the header stuff. So header follow target. This is going to be everything that has with our following to do. So I'm going to add a serialize field as well. Transform, which will be our follow target transform. Follow transform is null. So we'll set that to null. Then I'm going to have a way to kind of lock the camera in the Y direction, because what can happen if you follow the player too far up or down is that you get this kind of a unwanted camera clipping. So you can see parts of the world maybe that you don't want to see. Now, if you're making something like Flappy Bird or you're making something more horizontal, not like Metroid where you just have to go all the way up and down, you might want to lock the Y. So we're not really sure what we're going to make here, but I'm going to give you the option to actually lock the camera in a Y direction. It's good to know how to do that anyway. So for that, I'm going to add a Boolean, just call it lock Y, and I'll say give it a true or a false maybe from start, which is good. And then we need to have a way to check the minimum and maximum positions of these y values. So private lock y pos min, and I'll just give it 0f, and then copy that lock y pos max, if I can spell max, and I'll put that at 0 as well. Then I'm going to add my space because we're going to be adding more stuff here. But let's start with this. So we're going to add our exception thing in awake as well before we start coding the following. I'm going to say if follow transform is null at this point, we're just going to do the debug log exception new null system.null reference exception, and we're going to say follow not assigned, and it will tell us what script the exception is thrown from, so that we don't have to type that in. Just let us know what kind of is going on so we don't get too confused. So for now that's fine. Now we're kind of forcing it. Now I want to do camera movement here, and it's going to be very basic. So for now what we're going to do is we're just going to move the transform, and the thing is that later on you can add a rigid body to the camera. You can use something called Cinemachine, which is really nice. It's already a functioning library which you can use to move the camera in any way you want. So we might add Cinemachine later on, but for now we're just going to do a simple transform movement. So it won't be any kind of smooth transitions between states and smooth movements, but it'll be fine for now. So we'll just change the position is a new vector 3. Now what I'm doing here with transform is that whenever you call transform, it will get the component, the transform component of the game object, because it's already, or we can be sure that it's always there. So the transform is always there for each game object. That's why you don't have to do a get component for this. And we can easily change that. So we're going to make a new one, and what it's going to contain is going to be the follow transform dot position dot x for the x value. And then we're going to do all the lock y stuff. So if the y direction is locked, we don't want it to go past a point upwards and downwards. So it should be locked within that frame that we're given it. And to do that, we're first going to check if lock y is true. Now, if it is true, we're going to clamp by using something called mathf.clamp. Now, clamping is basically taking a value and making sure it doesn't exceed or go below a certain value. So we're just going to give it our value first, which will be obviously our y position. So follow transform.position.y. Now, what do we want to clamp this value to? Min and max. Well, we do have our lock y position min and max, right? So we're going to use that. Lock y pos min. So it wants the minimum one first, and it wants the lock y dot pos max for the maximum one. And what if lock y is not true? Well, then we're going to do a little else statement. And this is the way these statements, short if statements, work, is that you give it a condition, you check if it's true, well, then you do this, and if it's not true, you do this. So then we're just not locked, so it will just be the position.y, the raw position.y. And we really don't want to change the z position, so we're not going to do this. We're just going to say transform.position.y, and that's hard sometimes to get right, but what if we change the cameras, or this transform position, the follow position, the z value is off. It's going to mess with our camera, so we want to make sure our camera always stays to the z that we set it from start, so that we don't get any weird clipping issues or stuff doesn't disappear. Cool. So once that's done, I realized I made an error here, and it's easy to do. I'm going to remove the camera controller from the player, and I'm actually going to add it to the camera because that's where the camera controller should go. Silly me. So once you do that, then you can move your player to the follow transform, and we'll set a lock, or we won't set a lock actually. We'll just try it without the lock. So let me run this. There you go. Oh, we're getting some weird issues here. Yeah, so I made another error here, which you might have seen, is I said Y here and not Z. So I did just what I was not supposed to do. So, but that shows you what happens if you mess with the Z. So if I run this now we won't have an issue. Now the follow is working perfectly, no problems at all. So what I'm going to do is I'm going to lock the Y here, and I'm going to set the minus Y position, the minimum one, to -2 and the max to 2. And I'm just going to run this, and we're going to see hopefully that it locks. You can see that it just locks up on the top. And if I run off the edge, we're gonna fall down. So perfect. There you go. So now we can lock the camera position, and it will follow the player. Now what we're going to do is we're going to make sure the background follows the player, because if you see what happens with the background, it doesn't look natural. Obviously, the background shouldn't be static like this. It should follow the player constantly because it's so far away that it won't have a parallax effect. It shouldn't have one, in my opinion, at least not this background. But the middle ground should move a little bit along with the player, just telling us that it's a little closer to us. So how do we do that? Well, the background is really easy. What we're going to do is we're going to go to the code, and I'm going to remove my space here, and I'm going to add a header I can just copy the header actually. It's good to copy paste, save some time. Background. And then since we need a transform, I'm just going to copy the transform up here, place it down here, and I'm going to call it background transform. And we're going to set it to null. And I'll just add the exception at once here. Background transform, if that is null, we'll say that background transform is not assigned. And we'll do the same for the top here. Perfect. And while we're at it, we're going to just add the middle ground as well, because that's going to be the next step. So the middle ground, and then we'll call it middle ground transform. Add the exception as well, right below it actually. Copy paste that and say that the middle ground transform, maybe that's one word. I'm not sure. We'll keep it as one word for now, but that's perfect. So now we have these three here. Cool. And we're going to add some spaces between these, of course. Always good to do that and comment out the final one. Now we're going to make sure the background follows the camera. So I'm going to say background movement here, and I'm going to move the background transform dot position, and we'll do a new vector 3 as we always do, like that. Nothing new here. Now, where do we want to move this? Well, we want the transform to move not with the player maybe, but with the camera itself. So wherever the camera goes, the background will go, because the player might not follow the camera precisely later on. If we add some kind of smooth movement, the camera will kind of drag behind the player, but the background has to follow the camera and not the player, so it looks correct. So really simple here. We're just going to say that the X position.X right there for the camera, and then the Y will also be position.Y, the camera's Y position, but the Z will keep at the background transform. Wherever that is, we'll keep it there. We don't want to change the Z values. Cool. There you go. So now you have a background moving. What's going to happen now is if we don't have a middle ground, it's going to be weird. So I'm just going to say middle ground movement, middle ground transform is a new vector 3, and then 0f, 0f, and 0f. So we're just going to null it like that. Oh, dot position as well. There you go. So just null. And now we can try our background. Okay, so we got to test our exception here without even thinking about it. What happened was I didn't set the background transform. So you'll see that they're none. See, this is why this is so good. So now I'm going to add the background. I'm going to add the background transform to the camera. So this can be a little tricky sometimes. Usually I click the main camera and I say properties. So it pops up here. Now I can do whatever I want and it won't really disappear. We're not dependent on the inspector. So once I do this, I'm going to go down to where it says background, and I'm just gonna, whoop, that's not what I want to do. I actually want to move the entire background, not just that image. So I'm going to move that. Depending on whatever we add to the background later on, it's going to be a little better for us. We might as well go and add the middle ground here while we're at it, so we don't forget that later. Once that's done, I'll just close it and save the scene. Now if we try to run it, we should be fine. Whoa, there you go. Perfect. So the background is following the player perfectly. No issues here. That looks a lot better. That's how it's supposed to be. And you see when the camera locks, the background won't keep moving as well. So to add the middle ground movement, this is the actual parallax effect where the middle ground objects move along with the player a little bit. So it looks cool. What we're going to do is firstly, we're going to add a bunch of stuff. Now it's not only the transform. What we need is a few more things. We need some kind of a move scale factor just so we can scale the movement a little bit depending on how much you want the background to move or the middle ground to move with the player. And then we're going to limit, or we're going to allow the user to limit the vertical parallax, because sometimes you don't want it to be done in the vertical axis. Doesn't really make a lot of sense not to do it, but well, some people or some games don't have that. So we're just going to add that as an option. So first things first, we're going to do the scale factor, serialize field, private float, move, I'll just call it move scale factor, and we'll set it to 1f, so maximum. And what we're going to do now is we're going to add something cool. We're going to say range here. This is another Unity flag type thing. So 0f to 1f. And what this will do is we'll get a little slider, which will allow us to change move scale factor between 0 and 1. So we can limit that through the inspector, which is really nice. It's a nice way to change a variable. And the last one we're going to do is a private bool vertical parallax. And we're going to set it to true. Cool. And now to the code is not too much more complicated than any of these. I'm going to copy the background movement code actually, and I'm going to place it below. And I'm just going to copy paste that in there. Makes it a little easier. Don't have to type that whole thing again because the transform position.x, everything is the same. But here we'll say multiplied by move scale factor. So depending on the position of the camera, we'll multiply that by some type of factor. So the bigger this gets, it will be changed by the move scale factor. So if move scale factor is 0.5, our background position, if the camera is at 0 and the background is at 0, it's going to look just like this. But the more the camera moves to the right, so say the camera's position is at 100, the middle ground's position will be at 50. So it will just linearly kind of move like that. And you'll see that in action just in a minute if my explanation sucks. Let me just multiply the y as well with move scale factor. Well, that's actually dependent on the vertical parallax, if that's true or not. So we're going to firstly add a if statement. So vertical parallax, if that is true, then, whoops, what the hell just happened? What the hell just happened? Okay, true, spell that correctly too. So if that is true, what we're going to do is we're going to multiply it with move, can't spell, move scale factor, else it's just going to be whatever it was before. So Middleground transform dot position dot y, and then remember that the z should always be the same. So there you go. Once you have this ready, we should be able to jump into the inspector, click on your camera, and you'll see that your middle transform is set. It should be set since we did that before. And then you'll have a little slider here. So it'll be at 1 from start, and vertical parallax will be enabled. So if I run this, we'll see that 1 means that it will follow the camera perfectly. But if I put this down a little bit and start moving, it will move a lot less. If I put it to 0, it won't move with me at all. So we'll just stay. So if I say 0.2 or something, it'll be a really slow movement with the player. It's noticeable, but it's really slow. And 1 would be a perfect movement with the player. So that's how you can change that. It looks kind of cool. The only issue is that at the bottom here that we don't have anything below. So these should be either longer or they should be placed further down. So to fix that weird looking thing, what we're going to do is we're going to just go to our middle here, middle ground object, and we're going to set that to 0. And we're going to take all of our objects that we have and we're going to move them down to like -8 or something like that. Very specific. It's not like I have notes. And then what we're going to do is we're going to scale them to 5. So you click the little button here to enable constrained proportions. Oh, whoops. I think I did it the wrong way. So it should be enabled. And then we'll do 5. And now the fun part is where we have to find the middle one. I think it's the first one. No? Yeah, it's the first one. Okay, and then we're going to move these way out just so it looks correct. Let me just do this. I don't know if I did that right, but okay, we'll have the middle one and just control move that, control move that, control move that. Whoops, did I not have control? Okay, you want to make sure it's at least, whole numbers and not any weird decimal. There you go. I think they're all cool now. Looks cool. Good. Now if we go and look at our game, it looks a lot better. And we don't have, well, we have a lot more space to play with at the bottom. So when we're moving here, if I go to my camera again and I slide this down to maybe 0.2 and we run, oh, that looks a lot better. So our game looks like, well, a game now. And it looks a little more realistic. And this is nice. And there are a lot of problems you have to solve with this. Basically, you might not want this to, well, you don't want it to end somewhere and you want to make a Metroid type game. Well, then you can't really get away with a background like this. Not in every room. You might want a background that tiles vertically and horizontally, so it's unlimited. And you might not have a background at all. You just have the middle ground. So there's a few things you might have to think about. This isn't a, end all tutorial on that, but at least it gives you a direction to go in. So that's the middle ground and the background done. Quickly, just want to explain what's going on with DeltaTime and why we're not using DeltaTime right now. So you might have noticed, if some of you know what that is, it's basically a way to tell and get the time between each frame. Because sometimes if your game runs at a slower pace, say that if it's locked at 60, it's going to run the same on every computer. But if my computer is running at 60 FPS and yours is at 30 FPS, it's slower. It's pushing out less frames per second. And what happens is that if I'm moving something and adding a value to another value, for example, the velocity, if I'm adding something to it each frame, for me per second, it's going to add a lot less. Or for you, if your computer is slower, it's going to add a lot less during that second. So say that you're playing the game. Every second, your player is going to move a lot slower than what mine does. Maybe the game is intended to run at 60 frames. Then you don't need to use DeltaTime because you know that everyone will run at 60. If you're making an Xbox game that doesn't dip in frames, maybe. But still, it's a good thing to have DeltaTime going. So I'm just going to give you a very quick explanation of that, and we're going to do a full video on that later so that you know at least what it is. If I just open my good handy tool Paint here, let's draw a few frames. So I have a frame here and I have a frame here, and this is the time between the frames. And say that I have a circle, a character moving here. This is the first frame and the character ends up here in the second frame. Now we have a movement of this much between frames. And how much time did it take for that movement to occur? Well, it's the time between the frames, and that is our DeltaTime. So say that this is happening within 1 second. All of this is happening within 1 second. 1 second. So that's 2 frames pushed out. But if you have a quicker computer, say that that pushes out more than 2 frames, whatever. So for us, that delta time between the frames will be less. So this time here is less than the time up here. So to depict that, all I can do is I can move this kind of like this. So it's shorter time actually. Whoops. Okay, I'm just going to draw a new one. So this isn't the most beautiful drawing, but hopefully you can see what I'm trying to show here, that the time between the frames is less, but we're moving the character with the same amount of movement, the same number each frame. So remember, everything in games is done between frames, right? So the frame is just a representation of whatever your variables and everything is set at that given moment. So each frame is going to push out and the movement is going to be done between each frames. So our character started there, showed up here in the second frame, and the third frame is going to be over here. Now, if you see this movement should be the same for these two frames, but this movement within the same second, he'll be gotten further. He'll be further away from what the player sees on the slower computer. So what we usually do is we take the delta time value that we get here. So there'll be a set time between the frames, might be 0.01 seconds or something like that between this frame. And maybe it'll be way shorter on this one. But what that does is if we have a constant value here, like a speed value equals 10, what we'll do is we'll multiply that when we're moving. So if we say velocity plus equals, we'll say x plus equals speed. So this is what's happening right now. We're just adding it to the raw 10 each frame, no matter what the time between the frame is. So we'll move the same for everyone, no matter what the frame rate is. But to make it frame rate independent, what we have to do is we have to add a multiplied by time dot delta time or whatever, delta time. So we'll take the time it takes between each frame, which will be a really small value, and we'll multiply speed with it. So speed will be constantly changing depending on what the time is between the frames. And that's why you need to usually give speed a very big value, because time.delta time is so small that you won't even see the movement if you don't have a really big speed value to start off with. So if I say that speed is maybe 1000 F, we're going to start seeing some changes. And I'm going to show you some examples on this in a little bit, not in this video, but I just want you to be familiar with what this is. I don't want you to just understand this completely, but just know that when we're talking about delta time, what that is, it's between frames, why we're doing it, what the issue can be if we don't use it, and how it basically works, just shortly in a nutshell. So why we're not using it is because we're not adding anything. This is just a constant. So what we're doing is we are saying velocity is equal to whatever the axis is right now multiplied by the velocity. So the axis and all this stuff is already fixed in Unity so that it's kind of delta timed in the background and everything. So we don't have to worry about this. We don't have to worry about delta time here. But as soon as we start adding something, if I were to say velocity.x is plus equal to some arbitrary value, then we need to start using delta time. It's really important. If we use stuff like the physics engine, delta time gets a lot more relevant. So we're going to be looking at that as we go along. But for now, just know that if you see anyone using delta time, that's the reason we're not using it, because we're setting the value. We're not incrementing it every frame. There we go, guys. Sorry about the botched explanations. I thought I'd just throw in the delta time thing. I don't know. If you're more confused, I'm sorry about that. But it's good to look into, at least when you have the time. Hopefully you enjoyed this tutorial. We have a nice background moving around. You might want to set the default value of the move scale factor to something else, not 1, so you actually see the parallaxing effect. But it looks really good, I think. And now we're going to move on to tile maps and all the fun stuff of Unity. So it's going to be really cool. Thank you for watching. Drop a like, subscribe, all that stuff. Take care, and I'll see you in the next one. Bye-bye.